Hello everyone, I'm Sanjana Suresh, USN 1BM22CS 239, and today I'll be presenting on electric vehicle fast charging technology. So here's a brief overview of exactly what I'll be presenting in this presentation, which includes the introduction to electric vehicles, what is fast charging and what is the need for fast charging, how exactly fast charging works, the charging standards, certain policies and regulations related to fast charging, the recent advances made, and India's EV landscape currently as of 2025, the battery charging curve, and lastly, I'll be talking about certain real world applications of fast charging. So, starting off, one of the most exciting advancements in recent technology has been the rise of electric vehicles. They are changing the way we think about mobility, sustainability, and even our energy infrastructure. EVs are transforming transportation worldwide. They're cleaner, sustainable, and efficient. Global EV sales have reached 14.1 million in 2023 and is projected to cross about 25 to 30 million by 2025 as per the reports from International Energy Agency. But unlike conventional vehicles, they cannot be refueled in minutes. But one big question remains: how do we charge them quickly enough to make EVs practical for everyone? And that's exactly where fast charging technology comes in. Today, I'll walk you through the entire concept of fast charging. So, why exactly is fast charging required? So, traditional AC chargers can take up to 6 to 10 hours to fully charge an EV, which is inconvenient for daily commuters and long distance travelers. This traditional AC chargers, they are okay for overnight charging, but in case for regular commuting as well as long distance travelers, traditional AC chargers are not the answer. Whereas fast charging addresses this exact problem by reducing the charging time to 15 to 30 minutes, which is a considerable drop in the charging time. It makes EVs practical for long trips and commercial fleets such as taxis and buses. So here is a diagram that talks about how exactly fast charging differs from the traditional AC charging. So as you can see in this graph, we have the power output on the y-axis and the charging state on the x-axis. In the traditional AC charging, they maintain a constant speed of charging, and which therefore leads to a delay in the time taken to charge. Whereas in DC charging, you can see that there are multiple peaks. The highest peak that is reached followed by a constant speed. One more major difference between AC and DC charging, which takes up more time, is that in AC charging, there is an onboard charger that is present within the electric vehicle that converts the AC to DC. Whereas on DC charging, this conversion is already there present in the charging station itself. Therefore, it does not require as much time to charge an electric vehicle. Fast charging. So, by sending high current direct current straight to the battery, fast charging drastically reduces the time it takes to recharge. Voltage and current levels are carefully controlled to maintain battery safety and efficiency. So as you can see in this diagram, we have the power that comes from the grid, which is always the AC power. From the AC grid, it goes to the rectifier, which converts grid AC to DC. Later, we have something called as the power factor correction and filtering, which cleans the power and makes sure it doesn't disturb the grid. Following which, we have an onboard charger which is present in the electric vehicle, which converts the AC to DC. All of this is called as onboard charging. On the other hand, as you can see on the right side, we have the DC charging, which is also the fast charging. Here, the converter is already present inside the charger. It is also called as offboard charging. So the cars can be charged up to 50 to 350 kilowatts, whereas trucks can handle charge up to 3 megawatts. We also have certain control systems which monitor voltage and current for safety. Charging standards. So what exactly standards mean? Standardization ensures interoperability and convenience. So when we talk about standardization, it means that any EV can use any charger. So the ISO 15118 allows automatic authentication, billing, making charging as seamless as refueling a petrol car. It also enables V2G integration, which states the vehicle to grid integration. So we have various connector types. So as you can see the diagram, different plugs, and each of these have a different charging system. So for example, we have the CFS, which is majorly used in Europe and US. We have the CHA demo, which is a Japanese standard. We have NACS, which is related to Tesla and US, and GBT, which is related to China. Now, let's move ahead with policies and regulations. So, the governments worldwide are encouraging fast charging through funding, regulations, and incentives. These policies ensure chargers are safe, interoperable, and accessible to the public and readily available. In the European Union, uh, the policies and regulations states that 350 kilowatt chargers are found every 60 kilometers and on highways so that nobody is stranded on highways. Whereas in US we have the NEVI system, which states that about 5 lakh public chargers are readily available and which plug-in charge is required. Now moving on to India, we have the FAME 2, which focuses on urban and highway charges. Now let's delve a bit deeper into this FAME 2 scheme, what exactly it is and how does it benefit us. So FAME stands for Faster Adoption and Manufacturing of Hybrid and Electric Vehicles, which was launched by the Ministry of Heavy Industries and Public Enterprises to give a boost to development of electric vehicles. So this states that subsidy can be claimed by two-wheelers, three-wheelers, electric and hybrid cars and electric buses which come under the scheme. So we have various ways in which it's implemented, like establishing charging stations, incentivizing buyers, and publicizing benefits of electric vehicles. Now, let's talk about the recent advances in fast charging. Technological improvements have allowed for faster, safer, and more compact charging stations. Companies are testing megawatt level chargers and using advanced materials to increase efficiency. The image is of SiC electronics, which stands for silicon carbide. So as it's stated, it has a higher efficiency and smaller charger. Silicon carbide is a new semiconductor material that allows about 98 to 99% in power stages efficiency, smaller, cooler, and lighter charger, as well as also wastes less heat. Apart from this, we have other batteries like solid state batteries, which have an ultra fast as well as longer lifespan. We have certain liquid cooled cables which safely transfer high currents, and megawatt charging in trucks and buses. Now, let's shift our focus from the global to India's landscape about EV. India's electronic vehicle ecosystem is dominated by two-wheelers and four-wheelers. Fast charging networks by Ather and Ola are making daily commuting practical, while Tata Power and others focus on cars. So the game changers of India's electric vehicle landscape are definitely Ather, Ola. The Aether grid has about 1,800 plus fast charging and 100 plus cities, and it's constantly and rapidly growing. We have the Ola Hypercharger, which is the world's largest 2-watt network under rollout, and we have Tata Power and Static, which is 4-watt public charging expansion. So this map talks about the widespread fast charging regions in India by Ola, and on the other hand, we have the Tata Power e-charging station. Now, let's talk about the battery charging curve. So, when we talk about fast charging, we need to ensure that fast charging is just not about power. Battery chemistry dictates charging speed. Rapid charging at low SOC is safe, but high SOC requires slower currents to ensure longevity and safety. So, what exactly is SOC? SOC stands for state of charge. So the charging curve talks about the charging power peaks and state of charge. As you can see in the graph, we can see that from 0 to 40% of SOC, it has maximum speed. So you can see there's a steep increase in the charging power. The battery is warm and it's normally between, and the peak is already reached early. From 50 to 80%, so as you can see, we have the power level which is below the peak for majority of the charge. You start tapering to protect the battery to ensure the battery is efficient and remains for a long, can be used for a long period of time. From 82%, you can notice that the slow constant voltage phase, the charging power will decline sharply around 80%. Now I'll be mentioning about the infrastructure and cables. Fast charging is not just about power, it requires intelligent infrastructure. Cooling, modular design, and smart grid integration insulation ensures efficiency and safety. We have liquid cooled cables which can handle up to 500 amperes safely. So the images right on the left hand side are liquid cooled cables. You can see the various layers that are present in the cooled cables, which includes the signal cable, the signal line, the sheath, and the tape. Other examples of this infrastructure include modular hubs which have multiple chargers per station. Now let's talk about certain real-world global examples which talk about Tesla V4 superchargers, Ionity, Watt EV, and Kempower, which is the modular SiC-based chargers, which is upcoming and constantly growing. Lastly, in order to summarize the entire presentation, fast charging technology is shaping the future of mobility. By combining high power, smart control, and safety measures, EVs are becoming practical for everyone, from city commuters to long distance travelers. Fast charging, in particular, removes the biggest barrier to EV adoption. Recent advances include the SiC solid state batteries, 500 kilowatt plus, and megawatt chargers. In India, we have 2-watt fast charging networks which are growing rapidly. And here are a list of certain references from where the information has been collected and the references of the images. Thank you.